Hi, welcome everyone. In this video I'm going to show you how to set up an environment where you can develop your 3D scanning and motion capture exercises, and potentially it can be useful also to set up the environment to run your final projects. So a couple of things to mention. We have this repository, which is what I'm going to show you, and then there's also this repository which runs in GitHub codespaces. However, as far as I know right now, there are some issues with this codespace, and it doesn't work for everyone. So the steps I'm going to describe here today can also be applied to this repository, but you need to do it yourself. And the changes will need to be done in this install script. So this is the repository I'm going to show now. It's called 3D Scanning Environment. What it does, it creates a Docker environment where you can run your exercises and install dependencies, since it will have everything compatible by default. So the first step is installing Docker on your machine. You can check Docker for this. This is not going to be a tutorial on Docker, but it's very easy to install. Once you have Docker installed on your machine, you can clone this repository. So we can clone this repository, and then we go inside the folder. We have the following files. I'm going to show you now a bit what is the content of this repository, because even though it's not a Docker tutorial, it's important to know what we are doing. So as a recap or summary, Docker allows you to define state. In this case, the state is defined by all the packages that we want to have in our virtual machine. Even though it's not a virtual machine, Docker creates something called containers, which are much more lightweight than virtual machines, but for our purposes, we can understand data as virtual machines. So basically what we do is install the dependencies, specify the correct compiler version, which actually it's one of the issues most people have, especially on Windows and Visual Studio. And then we install glog and seres. As you can see here, commented out, there are instructions about how to build it from the repository, both for glog and seres. Instead, we are going to install it through the package manager because it's much faster. But if for some reason this doesn't work for you, although it should, you can uncomment this and comment this one, and then it should work. So now let's build the Docker image. This is the command you need to execute inside the folder. We will paste it. Now this command is going to take a while, so I will cut the video here. It might take around 5 minutes, depends on the machine you are using. But basically what it's going to do is execute all the instructions specified here, and then have the virtual machine ready for you to be executed on a later step. Okay, so the Docker image finished building, and now to execute it, we need to run docker compose app. Okay, as you can see, once it shows message done, means it finished creating starting the image, and now you see this URL with the port 8443. So what you have to do is go to localhost and the port that it shows, and you will see that it's showing this page. This page is Visual Studio Code for the ones that you are familiar, like an editor, but it's going to run on the browser. And as you can see, it asks for a password. If you check here the Docker compose file, you can see the configuration for this application, and you can see that the password is password. You can change it to whatever you want, and also that the sudo password is as well password. So as you can see here, we'll introduce password, enter password. Okay, can set up everything later. And now we are in the editor. And the important thing is that this editor is running inside this virtual environment with all the dependencies that we created, right? So we will do an example now where we will go to exercise 5 and we will start downloading and compiling the exercise to show that it works. So first we will open a new terminal. Okay. And as you can see, this terminal, you may notice, if you're familiar with terminal, is that it's not the same as you are used to see in your computer. That's again because you are inside this virtual environment, this virtual machine. Okay, so now with the setup for the exercises, you know that in exercise 0 or 1 we specify the structure, and this is like the following. We create a folder of exercises and data. Okay, and now we will download the data file. We will go to desktop. We will put it inside the repository that we cloned, inside files and data, which is the folder we just created here. As you can see now, when I save it, it will show inside virtual machine. We will do the same with exercise 5 zip. We clone it inside exercises. And the same for flan. Again, flan should be saved inside the libs folder. Right, so inside exercises libs, we save flan. Okay, now we have everything. Meanwhile, we will also copy the remaining data, which is from the Freiburg dataset, the first one. Sorry. So we download the compressed file, and again we save it under data. And this will take a while to download, but meanwhile what we can start doing is uncompressing the data. So if we go to data, which is this file, we need to unzip the data folder. For that, we need to install the unzip program, and again the password, as we have defined in the Docker compose file, it's password. You can set it up to whatever you want, or just leave it like this. Cool, so now we install this. We can now unzip the data folder. If we go to exercises, we can also unzip exercise 5. And if we go to the libs folder, we can again unzip the flan library. Perfect. Freiburg dataset finished downloading, as you can see here. So we can also go to it and unzip it. So in this case, we need to extract with tar, and it's going to unzip the video sequence for this dataset. Perfect. So now we can finally go to exercises, exercise 5. And yeah, let's go here actually. Can exercise 5 and the CMake. Now you can execute this. So what we're going to do is inside the exercise 5 folder, we are going to create a directory called build. We will go into that directory and execute CMake. You can also install the CMake extensions to make this with a user interface, but yeah, I prefer doing it with the command line. So if you want, you are free to use the extensions to use CMake. So now we execute CMake, we execute make, and now it's going to compile the binary for the exercise 5. Cool. So as you can see, it compiled successfully. If we try to execute it, we might face an error. Yeah, complaining about, as you can see, it's an error saying failure to initialize visual sensor. Why is that? Yeah, it's very simple to fix. So as you can see, we initialize the virtual sensor. Let's see, virtual sensor. Yeah, here, as with this path, this path. And yeah, this can be wrong because of the folder structure we created. So if you try to go to that path right now, so inside the directory, if you try to list this directory, you will see that it doesn't exist. But that's very easy to solve. We just need to change it to this one. Right, and now it will work. So, I mean, I guess at this point everyone is familiar with the structure of Linux, but this is just telling that this folder is located at current directory, go to the parent, and then data. So, yeah, we need to go one level higher, that's it. So if we change it, so we add one more parent, and we save the file. Now we compile again. Perfect, now we can execute it. And as you can see, it's able to read the files, it's finding nearest neighbors. But yeah, all this it's not valid because the exercise is not implemented. So that's the part you will need to do. But as you can see, it builds successfully without much issues. So maybe one more thing, which is, as you can see, right now we are using the terminal built into this, in the browser. But additionally, if you want to, you can copy this command. And if you open a new terminal in your computer, you can execute this. And now again, we are inside this virtual environment. So in case you prefer it, that's also an option. And as I mentioned, the files directory is where is shared with your computer. So that's why we were able to download all these files directly into this virtual machine. And that's it. To shut down the environment, I mean, you can close just the window, and then in your terminal that you run Docker Compose app, you can just Control-C, and it will close the environment. Next step, you want to run it. It's very easy as well. Let's make an example. We go to where we clone the repository, and again we just do Docker Compose app. Right, as you can see, same URL. So if we go to localhost and the port, we put the password that we had set up at the beginning. And as you can see, we are in the same environment. So everything should still run. So if you go open a new terminal, right, we go to the exercise folder, exercise 5, that build directory. We can run it, and it's still working. And finally, as I mentioned, there's this GitHub codespace, and it's the same concept. So it's basically creating kind of a virtual environment. The difference is that with this one, you do it in your local machine, and that means if you need a lot of resources or compile or execute stuff, this is going to allow it to do it in your local machine. And I think it's particularly useful, especially when you want to work with on your projects. Here you run it on the GitHub servers, and basically you can fix this repository by changing the install sh and executing the same steps as we did in our, let's see if I can find it, in our Dockerfile. So you install all these dependencies, right? So you come here and you see that it's sudo apt-get. So I mean, probably they are the same. The only difference comes from installing glog and Ceres. You will need to replace it with installing the package instead of compiling it, and the same for Ceres, and that should be it. And maybe also the C++ version. Right, hope this is useful, and see you next session.